This video is for 3.6, Comparing Expressions with Exponents. Throughout this topic, you have studied the properties of exponents, and you can use the property of exponents to write equivalent expressions, which you already know what they are. There are two expressions that equal the exact same thing. So 20 plus 4 is equivalent to 2 times 12 because they're both going to equal 24. This wants us to go ahead and find four expressions that are equivalent to 2 to the 13th power, and then you have to be able to prove each one. So the first one I'm going to say is if I have 2 to the 10th power times 2 to the 3rd power, I could go ahead and add my exponents and I could have 2 to the 13th power. If I had, say, 2 to the 8th power times 2 to the 5th power, then when I added those together, I would get 2 to the 13th. If I had something like 2 to the 15th over 2 squared, then I could go ahead and I would subtract my exponents, leaving me 2 to the 13th. If I had 2 to the 19th and I had 2 to the 6th, I would subtract those and get 2 to the 13th. On these notes, I want you to go ahead and find four other expressions that are going to be equivalent to 2 to the 13th. So go ahead and find your own, make sure they work and that you can prove them when you turn them in. This wants to know what expressions are equivalent to 5 to the 8th power. So we're just going to go ahead and work each one. So this first one, I'm going to take my base and I'm going to keep it the same. So 5 is going to be my base, and then I have 5 to the 1st times 5 to the 8th. I'm going to add those exponents and I'm going to get 5 to the 9th. Then on the second one, I'm going to have 5 to the 2nd times 5 to the 6th. When I multiply them, I'm going to add my exponents and I'm going to get 5 to the 8th. On my third one, I'm going to have 5 to the 16th over 5 squared. So I'm going to keep my base and I'm going to subtract my exponents. So 16 minus 2 is 14. And then on the fourth one, I have an exponent, so a power of a power. So I have 5 squared and then that to the power of 4. So I'm going to multiply these two together. So I'm going to have 5 to the 8th power. So now I'm going to go back up to my question. I'm going to see which expressions are equivalent to 5 to the 8th. Well, that is number 2 and number 4. This part is also a review, so it says to drag the appropriate symbol to make the expressions true. So first we're going to go ahead and find out what each side is. So for A, we have 3 to the 6th power, and then on the other side we're going to have 3 squared times 3 to the 3rd. So we're going to have 3, and then here we're going to multiply the 3 squared times the 3 to the 3rd, which means that we're going to add our exponents. So I'm going to have 3 to the 5th power. Well, 3 to the 6th power is going to be larger than 3 to the 5th power. So we're going to go ahead and put the greater than symbol in. Here we have, for B, we have 7 to the 4th. And then on the other side, we have 7 to the 8th over 7 to the 4th. When we have these that are dividing, then we go ahead and subtract our exponents. So those two are going to be equal, 7 to the 4th on both sides. The last one is 1/4 to the 16th power. Well, remember that we have an invisible exponent of 1 next to each of those. So I'm going to take the 16 times the 1 on both of those. So I'm going to have 1 to the 16th, which is just 1. And then I'm going to have 4 to the 16th. On the other side, I'm going to have 1/4 to the 8th power and 1/4 to the 2nd power. So I'm going to keep my base the same, which is 1/4, and I'm going to add my exponents. So that's going to be 1/4 to the 10th power. So that's 1 to the 10th power, which is just 1. Because any one that is multiplied by itself 10 times is still going to be 1. And I'm going to have 4 to the 10th power. So when I go ahead and work these through, this one, 4 to the 10th power, under 1 is going to be greater than 1 over 4 to the 16th power. Because remember, the 4 to the 16th power is going to be a lot larger number. Quick example is if we have 1 divided by 8 or we have 1 divided by 4. Well, if I were to have pile of brownies and they were divided into 8 pieces, one brownie mix divided into 8 pieces, I would get a smaller piece than if it were divided into 4 pieces and I were to get one. So remember that on our bottom, when we're using a fraction and we're looking at the bottom number, we want it to be a smaller number, and that gives us a larger piece because it's cut into less pieces. Go ahead and pause it and see if you can go ahead and find which answer is correct. Okay, now that you're back, I'm going to work through it for you. So we have 9 to the 36 over 9 to the third. Remember, we're going to subtract our exponents there. So I'm going to have 9 to the 33rd compared to 9 to the 12th. Well, that number is going to be larger than 9 to the 12th. So we're going to have 9 to the 12th is less than 9 to the 33rd. This is already shown for you on your notes, so you don't have to take any notes, but I wanted to make sure that I was explaining it. You notice that our bases are not the same. One is a 5 and one is a 28. So we want our bases to be the same to be able to compare them. So when we have 5 to the 28th power, and then we're going to compare that 25, we can know that 25 is the same as 5 squared. So we have 5 squared here, and then we have it to the 19th power. Is basically the same thing. So we're going to go ahead and solve out this part. We're going to have 5, and then we're going to multiply the 2 times the 19, and we're going to get 38. So we have 5 to the 38th compared to 5 to the 28th. Well, now it's really easy to see that that is going to be larger because we have the same base, so now we're just comparing the exponents of 28 and 38, and of course the 38 is larger. Okay, let's try a couple of others that are like it. First, we're going to look at our bases. So here we have a 3 to the 18th. Here we have a 9 to the 10th and a 3 to the 3rd. Well, we know that 9 is the same as 3 squared. So we're going to go ahead and we're going to make all of them 3. So I'm going to leave this 3 to the 18th on this side, and I'm going to change 9 to 3 squared. And then I'm going to say that 9 is to the 10th power times 3 to the 3rd power. Now we're going to go ahead and solve our parentheses first according to PEMDAS. So I have 3 to the 20th power times 3 to the 3rd power. Well, we know at this point that we're going to add our exponents. So I'm going to keep my base the same. I'm going to add my exponents. And so I have 3 to the 23rd, and I'm going to bring down that 3 to the 18th. So now we're just comparing, since our bases are the same, the 18 and the 23, and the 23 is larger. So this is going to be our answer. Let's look at the next one. So we're going to look at our bases. We have a 2, an 8, and a 4. So when we're doing this, we want to go as small as we can. Once I am knowing that, then my 2 is the smallest, and then I'm going to take a look. 4 and 8 are both factors. 2 is a factor of both 4 and 8. So 2 squared is going to be 4. So I'm going to change that over, and that's going to give me 2 to the 42nd power. On this side, I'm going to have 2 to the 28th, and I'm going to keep that part. And then the 8 I know is the same as 2 thirds, or 2 to the 3rd power. So I'm going to put in 2 to the 3rd power in place of the 8, and that to the 4th power. So I have 2 to the 28th times 2 to the 12th, because we're going to multiply those. Now that we've multiplied those, now we have these two, and now we're going to add, because we have the same base and we're multiplying those bases together. So we're going to add them, and we're going to get 2 to the 40th. And here we have 2 to the 42nd. So we're just comparing our exponents again because we have the same base. And we can see that the 4 to the 21st is going to be larger than 2 to the 28th times 8 to the 4th. Okay, give this last one a try on your own and see whether or not it will, you can find the right answer. So go ahead and hit pause. Okay, now that you're back, you're going to look at all of your bases, and you're going to find the smallest base. Well, we have 27, 3, and 9. So when we are looking at those, the 3 is obviously the smallest. So then we're going to start looking and seeing, can I make my bases the same? Well, 3 squared is going to be 9, and 3 cubed is going to be 27. So now we're going to go ahead and work those through. If you're not sure about that, you can just go ahead and multiply them out. 3 times 3 is 9. Another 3 is going to be 27. Okay, so over here we're going to have 27 to the 5th is going to change to 3 to the 3rd is going to be the 27, and then that to the 5th power. And on this side we have 9 to the 8th over 3 to the 4th. Okay, so on this side we have 3 to the 3rd times, or to the 5th power. So I'm going to multiply these two, and I'm going to get 3 to the 15th. On this side, I'm first going to have to make that 9 into a 3 before I can subtract. So 9 becomes 3 squared to the 8th power over 3 to the 4th power. Well, this becomes 3 to the 16th over 3 to the 4th. Now I'm going to subtract those exponents now that my base is the same. So I have 16 minus 4, and I'm going to get 12. So I have 3 to the 12th power and compared to 3 to the 15th power. So just comparing our exponents, we're going to see that this one, the 3 to the 15th, is bigger. So that means that 27 to the 5th power is larger than 9 to the 8th power divided by 3 to the 4th power. Okay, I hope that made sense. If not, go ahead and make sure that you've written down questions, and I will see you in class tomorrow. Thank you so much.